So question 5, part 1, sketch a graph. Now if this question doesn't have modulus, are you able to do it?
Yes.
Very easy, right? It's just a quadratic graph. Then if you're able to sketch y equals to 9 minus x squared, then you shouldn't have a problem doing modulus, because what exactly does modulus do? That's it. All the negative become positive. What about positive? They remain the same. That's it. Which means any part of the graph below the x-axis is reflected upwards into the y-axis. Okay, so let's begin. We shall first sketch y equals to 9 minus x squared. And this will always be our approach. Remove the modulus first. Sketch what we can. So sketching of 9 minus x squared is not difficult also. I know it is going to be a parabola. Does it open upwards or downwards? It opens downwards. How do we know?
X squared, negative x squared.
You look at the coefficient of x squared, it is a negative, so it is going to open downwards. In other words, there is a maximum point. Okay? There is a maximum point, which we will have to find out also. Then we also need to find out the x-intercept. We need to know the y-intercept. These are the things that we need to know. Okay, out of all these, how do we start finding, for example, the x-intercept? Okay, x-intercept happens when y is equal to 0. That means 0 equals to 9 minus x squared. Go and solve it. You have x equals to plus minus 3. I know it is going to intersect the x-axis at negative 3 and positive 3. Okay, let us find out what is the y-intercept. When does this happen?
X equals 0.
Okay, it happens when x is equal to 0. When x equals 0, substitute in y equals to 9. Okay, I have the intercepts already. How then do I find the maximum point? Which of these intercepts do I make use of to find the maximum point?
X.
Okay, x-intercept. Based on the x-intercept, okay, it is at negative 3 and positive 3. It actually cuts my graph this way, negative 3. Sorry, cuts my x-axis this way, negative 3 and positive 3. What does that tell you about the line of symmetry? Where is the line of symmetry?
X plus x plus x equals 0.
Okay, the line of symmetry is a vertical line, yes? It has to be a vertical line. Vertical lines have the equation x equals something or y equals something? Vertical lines, yes. X equals to something. Based on these two intersection points, where is the line of symmetry? X equals to 0. That means my maximum point must be at
Y equals 0. And x equals 0.
x equals 0, otherwise known as the y-intercept. Make sense?
Yes.
The maximum point is at the y-intercept, which means 0, 9. Okay so far? Okay, so these are crucial points that we must have. Besides these 3 points, there are actually 2 more points that we need to show. Negative 5 and positive 5, because these are the endpoints that were requested for. So you have to show when x equals to negative 5, y equals to 9 minus negative 5 squared. How much is this? 16 or negative 16? Negative 16. I am now sketching this graph, y equals to 9 minus x squared. I am not doing modulus yet. Okay, so when x equals to negative 5, we have negative 16. When x equals to 5, y is again equal to negative 16. Okay, so I'm going to just redraw my axis, everything over here. Y-axis, x-axis, negative 3, positive 3. I know that 9 over here is important. When it comes to 5 and negative 5, we've got negative 16. Okay, so 9 is here, negative 9 should be here. Negative 16 is less than of 2 times. So you approximate somewhere around here. This will be my negative 16. So these are my additional 2 more points. So here if we join them, we should get a parabola. Okay, so join with a smooth curve, as smooth as possible. Okay, this is my graph of y equals to 9 minus x squared. But the question wants modulus 9 minus x squared. So I will have to flip all the portions that are below the x-axis upwards. In other words, these portions. I'm going to highlight these portions to be reflected upwards. The new y coordinate when x equals to 5 will be from negative 16, flip it up to become 16. Likewise over here. Join. And everything that is not included in the graph that you do not want the teacher to mark, dot it out. So here we have the graph of y equals to modulus 9 minus x squared. And this gives us 3 marks. Standard steps to follow. Okay, next. Find the coordinates. Okay, make sure you label the important points in your graph. In this case, because I indicated very clearly where these points are, I do not need to write the coordinates. But if you don't have dotted lines to help you, make sure you state it very clearly. Negative 5, 16, 0, 9, negative 3, 0, 3, 0, as well as 5, 16.
So
Yes.
let's start the open net paper.
Sorry?
I don't need this question now. Can I do a different net paper?
Yeah, if these questions you have no problem with them, you can start doing your next set of homework. Okay? Now we are moving on to part 2. In part 2, you are supposed to find the x coordinates for the points of intersection of this particular graph and y equals to 27. So it is the same graph and the line y equals to 27. You already have the graph, let's see what we can do with it. The line y equals to 27 is a horizontal line. It lies above, over here. Y equals to 27. If we extend the graph, we will see that it intersects only 2 times. There are 2 intersection points. They are definitely going to be less than negative 5 as well as more than 5. And we expect these 2 numbers to be symmetrical also. One positive, one negative, based on the symmetry of the graph. So in part 2, we are actually dealing with how to solve modulus equations. They are actually simultaneous equations. The first one is actually y equals to modulus 9 minus x squared. Equation number 1. Y equals to 27. Equation number 2. Sub 2 into 1. Standard way of doing our simultaneous equation with substitution. So we have modulus 9 minus x squared equals to 27. From here on, we don't have to be afraid of the modulus. You know what? The approach is very straightforward. All you need to do is to pretend that the modulus does not exist. We can all do that. Pretend it doesn't exist. 9 minus x squared is 27. Right? This is our next step. However, things will not be that straightforward. There is another different case. Or, now all you need to do is again, ignore the modulus. 9 minus x squared equals to, the change over here is on the right hand side. You put a negative, whatever is the right hand side. Okay, what is on the right hand side? 27. Okay, so it's simply negative 27. Sometimes the right hand side is another expression. It may not be a constant. That is why I included brackets over here. So this is how we move to the next step. We break down the modulus into two different cases. One is for positive, whatever is in the modulus. The other is for negative, whatever is in the modulus. And we solve these two separately. And we see what we get. From the first one, we have x squared equals to 9 minus 27. That's from the first case, isn't it? Does this make sense? 9 minus 27 is x squared. Meaning, x squared is actually negative, what's this, 18. X squared is negative 18. Does that make sense? No, it cannot be. X squared must be a positive or equal to 0. So this is rejected. This is nonsense. Next case. X squared is equals to 9 plus 27, which is 36. Are you happy to see this? X squared equals to 36? Yes, because we know that x is going to be plus minus 6. And does that correspond with our graph? We have indicated that it will be 1 less than 5, one x value less than 5, one x value less than negative 5, and the other x value greater than 5. It turns out it is simply a unit away. So these are the x coordinates of the points of intersection. Okay? Any questions before I move on to question number 6? Yes? What if you immediately draw the graph without the working? Without the dotted lines, yeah, it's okay as long as you have the correct shape. You have clearly indicated all the relevant and important points, meaning all the intercepts, all the turning points, and all these endpoints. Okay? Yes. Negative the. Okay, so let me use another color. Genesis is asking whether instead of writing it this way, we write down negative 9 minus x squared equals to 27, right? They are the same. Yes, you can do that. You can do the one in blue also. It's just that after this 9 minus x squared, you can divide it over with a negative 1, you get negative 27. It's the same thing. However you want to proceed. Any other questions? Otherwise, question 6. Differentiation and integration. Part 1. d over dx. We are differentiating. Make sure you have your presentation correct. X e to x.
Can you put yourself in y equals that one,
If you want to go do the extra step of writing let y equals to x e to x, then you move on to dy over dx, yes you can. But I must see this. If you want to use dy dx.
not just use y plus put that.
The question didn't say y equals 2.
Okay.
So you are letting y to be equal to. Okay? But I don't like to do this extra step. So I'll just straight away continue from here. Now I see that this is a product of two terms. Here we have x, or rather two functions. The other is e to the power of 2x. So clearly I must use my product rule. Copy the first function, which is x. Now I'm going to differentiate the second function. Differentiating x e to x. When you differentiate e to the power of anything, just copy it down. You have e to the power of 2x. Now we have to multiply this by differentiating the power of e, which is 2x. Differentiating 2x gives us 2. So we are done with half of the product rule. Plus, I have copied x and I have differentiated e power 2x. Now it is time to differentiate x and copy e to the power of 2x. So differentiating x just gives me 1, which normally I don't bother writing. Copy down e power 2x. We end up with 2x e power 2x plus e power 2x. Nice. Okay, 2 marks for this. Part 2. They gave you a clue. Use your answer in part 1 to show this. Now I can assure you, you have not learned how to integrate this yet. You will learn this in JC. But for now, you can actually do it by employing whatever result you have found in part 1. Okay? Recap, we have learned how to integrate fx with respect to x, where fx is a polynomial. X to the power of something, blah, 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 power plus 1 divided by new power, so on and so forth. We have learned how to integrate e to the power of something, fx over here. We have learned for ln as well, and so on and so forth. So today, these two are multiplied together. I can't do that straight away. So let's see what our previous part gave us. When I differentiate x e power 2x, I get whatever is on the right hand side. So using integration as a reverse of differentiation, okay, integration is the reverse of differentiation. If I were to integrate the right hand side, what do you think I will obtain? If I integrate this, what will I obtain? Whatever was in the original function. Okay, so let me write down that first. That is my key to solving this problem. When I integrate 2x e to the power 2x plus e power 2x with respect to x, when I integrate the right hand side with respect to x, I will obtain x e power 2x plus c. Make sense so far? Okay, but here we have a definite integral from 0 to 1. So let's add that in, from 0 to 1. When I integrate this from 0 to 1, I will get my right hand side also from 0 to 1. Do you agree? What about the c? Does it still exist? No, the c will be cancelled out already. As of this step, all okay? Okay, let's move on. We have integration of two terms added together. Which term are you actually interested in? The first one or the second term? First term, right? Look closely at what part 2 wants. Integrate x e 2x. I see an x e 2x over here. If only there's a way to isolate just this part. Actually, can we do that? How do we do that? Yeah, can I just split my integration? Can I split my integration since there are two integrals added together? I can do that. So here we have 0 to 1, 2x e to the power 2x with respect to x plus integrate from 0 to 1 e power 2x, differentiate this with, integrate this with respect to x, and on the right hand side we simply have x e power 2x from 0 to 1. Okay, let's take a look at this again. Is the right hand side manageable? Do you know what you have to do with the right hand side? Simply substitute, isn't it? Okay. How about this? Is this manageable?
Yes.
Integrate e to the power 2x.
Yes.
Definitely. It's one of the easiest integration that you can do. How about this? Do you know how to do this?
Cannot.
You cannot do that, right? You still haven't learned how to do this. However, you are able to do these two. Which means that I can make this the subject and I can work things out. Okay, so let's do that. Integrate from 0 to 1, 2x e power 2x dx is the same as x e 2x from 0 to 1, which you told me you can do that. Minus away, okay, let's do the integration now. E power 2x, let's integrate that. What do we get? Really? 2e power 2x? Are you doing differentiation or integration? E power 2x with a half, or rather over 2, right? This is what we get when we integrate e power 2x. And this is from 0 to 1 also. Can? Now are we getting closer and closer to integrating from 0 to 1 x e power 2x? What is the difference? What is the difference between what I have and the question that is required from us? Divide by 2. Okay, we see that there's an extra 2 over here. I can simply bring this out. It is 2 multiplied by. So put it over here. Remove this. And now, to really answer the question from 0 to 1, x e to x dx is actually half of over here. And I believe you can solve this already. Okay? Work this out. You will have this to be shown equals to e squared plus 1 over 4. The work solution in your TYS use a slightly different approach.
I actually don't understand what you're doing.
Okay, but do you understand this?
Yes.
Okay, then use this. Okay?
So, but I didn't do the, I didn't put the number for the binding.
You didn't put the numbers for the square brackets?
Yeah, on the left side and the right side, I never put the 1, 0.
If you didn't put a 1, 0, then I expect C to keep appearing. The plus C. When you integrate, you will have a plus C, right? So when you do indefinite integrals, these are indefinite integrals without the boundaries 0 and 1. I expect to see a plus C. So if you tell me your square brackets don't have 0 and 1, I expect to see plus C somewhere. Then subsequently, when you introduce the 0 and 1, that is when your C can disappear.
Must my C be like C1, C2, C3?
It depends on how you are going to present it.
Can I just write the same C for all?
I have to look at your working. Okay? Are there any other questions for 2010, paper 1, question 6? Otherwise, moving on to question 10. Without use, yes? What if you know how to integrate? You really know how to integrate this? Oh, okay. Okay, so class, Darius. So there's a question. What if you actually know how to integrate this? That means you do not use the result from part 1. Then are you following the instructions? No, you're not following the instruction. Then they can penalize you. Okay, so you have to be very careful about these words over here. Use your answer to. They want to see how you employ this technique. That is where they are grading you. Things like hence, therefore, using your answer in part 1, you have to follow the instructions because they are testing you on a specific set of skills. Okay, right now, question 10. Without using calculator, show tangent 75 equals to 2 plus root 3. 4 marks. Just a few words, 4 marks. Okay? Now, tangent 75 degrees. 75 degrees is an angle that is not one of those common angles that we see. What are some common angles? We've got 30 degrees, 45 degrees, 60 degrees, okay, 90. We can have 0 over here, so on and so forth, right? These are some common angles. And we've actually got a table which you are told, which you are supposed to memorize: sine, cosine, tangent, 30, 45, 60, and maybe 90. But did I tell you to memorize? No, I didn't tell you to memorize. You can actually use your calculator. You can use your calculator and I will demonstrate in a while. So tangent 75 degrees, we are supposed to break down this 75 into a combination of these angles. How many options do you have actually? Seriously?
1.
Yeah, you only have 1, right? So tangent 75 degrees is the same as tangent 30 plus 45. And now you can refer to your formula list, or if you have already memorized it, good for you. Tangent 30 and is it plus tangent 45 over 1 minus tangent 30 tangent 45 degrees. Okay, if you did not memorize, make sure you copy down the formula and apply it, substitute it accurately. Now, tangent 30. I'll be honest with you, I did not memorize tangent 30. So I'll use my calculator, make sure it is in the degree mode. Tangent 30. Oh, I see 0.577. I recognize this number. Do you recognize this number? You don't recognize this number? What combinations are there? You know that, okay, within this table, we have either zeros, we've got our halves, we've got root 2 over 2, root 3 over 2, root 3 over 3, and 1, okay? These are some numbers. What do you think this is? If you're unsure, why not just test it out? I suspect it is, for example, root 3 over 2. I suspect, okay, so minus away root 3 over 2. Oh, it is not root 3 over 2 because when I subtract it, it didn't give me a 0. Understand what I'm doing over here? Okay, let's move on. Tangent 30. So this is the value which I want to find out. I'm going to subtract away. I'm now guessing it is a root 3 over 3. Root 3 over 3. Oh, it's 0. What does that tell me about tangent 30? Root 3 over 3. Doesn't take you long to do that. So this is root 3 over 3 plus tangent 45. It's actually just 1. Okay, so tangent 45. Although they say you're not supposed to use your calculator, but this is what you can do to overcome that. Plus 1 over 1 minus tangent 30 again, root 3 over 3 times 1, which I don't bother writing. Okay, so now, does this look like this? Totally not. Doesn't look like it at all. But we can manipulate that. This is now a surds question. Okay, but before I employ the surds, I want to multiply by 3 because I rather have a numerator and denominators without fractions. Multiply by 3 throughout. We arrive at root 3 plus 3 over 3 minus root 3. Now we need to rationalize the denominator. And we do so by multiplying. Okay, class, everybody look up. Whether you know how to do this or not, please look up. We're going to rationalize 3 minus root 3, meaning I do not want any square roots in my denominator anymore. What should I multiply this to? 3 plus square root 3. What property are we actually using over here? A square minus b square is a plus b, a minus b. Very good. So when you multiply the denominator by 3 plus root 3, we have to do the same for the numerator. 3 plus root 3. And hey, it's just going to be squaring it. Okay, fine. 3 plus root 3. So now, expand the numerator. I tried to rub my nose. Okay, root 3, we're going to square that. Square of root 3 will be 3 plus 2 times of root 3 times 3 plus 3 square, which is 9, divided by, please do not go and actually work the denominator out. You should know that this will be a square minus b square, which means it is 9 minus 3. Because root 3 you square, you get 3. Okay? So let us simplify. 3 plus 9, we get 12. Plus 6 root 3 divided by 6. Simplify it. 2 plus root 3. And shown. Can? Yes. You put 1 over, okay, so this part is 1 over root 3. Yeah, it is, you will get the same answer also if your subsequent working is correct. Okay, I can help you find your mistake later on. Okay? Now for part 2. Since we have already shown that tangent 75 is 2 plus root 3. What about secant square? What is the relationship between secant square and tangent? if you are lost, look at your formula list. Okay, it's at the front. See if there's anything that relates.
1 minus cosecant equals
Hey, this is secant. I don't want cosecant. See if there's something relating secant square and tangent. Oh, here. Secant square A is 1 plus tangent square A. Quite close, right? Okay, so secant square 75 is 1 plus tangent square 75 degrees. Can we actually do this? Yeah, you will be using your answer in part 1. 1 plus tangent 75 degrees, and I square it. Tangent 75, what is that from our part 1? 1 plus 2 plus root 3, and we square this. 1 plus 2 square, 4 plus 4 root 3 plus 3. And we have 8 plus 4 root 3. 8 plus 4 root 3. Factorize out 4. 2 plus root 3. Now we see that secant square 75 degrees is 4 times of 2 plus root 3. This 2 plus root 3, is it familiar? Yes, it is our tangent 75. Replace this with tangent 75 degrees. Shown. Any questions? Okay, otherwise, last question. Question 12. Okay, so let's begin. Write down the equation of a circle with the center -3 to radius 5. For part 1, you can write it down straight away. X plus 3 square plus y minus 2 square equals to 5 square. Okay, 5 square, you leave it as 25. So this is very similar to our format for Pythagoras theorem. Okay, you can leave it like this, or you can choose to expand it out. Both will be accepted. Next, it tells us that the circle intersects the y-axis at P and Q. Intersecting y-axis, by now you should be very familiar. They are telling you, substitute x equals to 0. Intersecting the y-axis just means x equals to 0. Therefore, substitute x equals to 0 over here. Then you will have two values of y. Okay, let's see what happens over here for part 2. 0 plus 3 square plus y minus 2 square equals to 25. Continue solving it. You will have y equals to 6. Okay, you will show the factorized form first. Y minus 6, y plus 2 equals to 0. From here, you have your two y values. Y equals to -2 or 6. These are the two y values. Next, find the length of PQ. From -2 to 6. One of them is P, one of them is Q. It doesn't matter which you assign to be which. They're asking for the length. So from here, quite clearly, the length will be 8. In fact, we don't even need to do any calculation. So 8 units for part 2. Okay, the next question, part 3. A second circle, center B, this time there's a different center, passes through P and Q again. Okay, so the first circle is on the left. Something like this. The second circle, center B, passes through P and Q. State the y coordinate of B. Y coordinate of B, given that the x, state the y coordinate of B. Okay, sure. For a circle that intersects the y-axis at -2 and 6, how many other circles can you draw? You can draw an infinite number of circles, but they will generally look like this. Okay, or maybe smaller circles, or they will be on the other side, or bigger circles. Okay, these are all the circles that we can draw. There are infinite of them. But where is their center? Do you notice that their centers are all along the same horizontal line? And what is so special about this horizontal line? It is not the x-axis. Okay, my scale is not drawn very well. Let me do it properly. -2 and 6. Okay, so circle over here. And we can have bigger circles and smaller circles and so on and so forth. So what do you see as the centers for all these circles? What is common? All of them have the same y coordinate. All the circles lie on the same horizontal line because they intersect at 6 and -2 on the y-axis. So this horizontal line must definitely be right smack in the middle of -2 and 6. So what is the middle of -2 and 6? So y coordinate is the average or the center, 6 plus a -2 divided by 2. So we have 4 divided by 2, it is 2. Okay, we actually can see that from this y coordinate also. Now they tell us that the x coordinate of B is positive, meaning the circle B largely lies on the right hand side because the x coordinate is positive. They tell us the radius is √80. Find the x coordinate of B. Okay, we have quite a number of options that we can do, but the format,
How do you know which is B, which is Q?
it doesn't matter. It doesn't matter. All you needed to do was to find the length for part 2. And then in part 3 and part 4 and part 5, you do not have to refer back to P and Q. You don't need to assign them actual coordinates. Okay, so we are going to make use of the radius. We are going to make use of the y coordinate of B, as well as any one of these 2 points. Okay, so the general equation, the center, let, I'll be following the format shown in your TYS because that's a good presentation. Let B be k, 2. We know that the y coordinate is going to be 2 already. We just need to find the x coordinate. It is an unknown that it be equal to k. So we also know that BP, which is the radius, from B to P, whether it's B to P or B to Q, we get √80. Radius equals to BP √80. Okay. Then we have from the length B to P. We are trying to find the length from B to P. So we can use the formula for the length of a line segment. X coordinate k minus the x coordinate of P. For example, for either P or Q, x coordinate, they are both zeros, minus 0 squared. We are going to add this to the y coordinate of B minus away the y coordinate of either 6 or -2. You will get the same answer. Minus 6, we square it. Now this radius is supposed to be √80. From here, you continue solving. You get k equals to 8 or -8. Of course, -8 has to be rejected. The question told us that x coordinate of B is positive. So now we have the center of B. This value is 8. 8, 2. This is now my center of the circle. Now in part 4, we're done in part 3 already. Moving on to part 4. The equation of the circle may be written in this form. You have to be familiar with this also. Find the value of G, F, and C. You can follow what the suggested solution is. That is, you write down in the completed square form. And you solve by inspection. You compare the x, the coefficients. The other way is to do it directly by knowing G over here. Since my center is 8, 2, this tells me that G is going to be -8. It also tells me that F is going to be directly, we can find out the answer, -2. Because this is the format. We know that this G value and this F values, they are actually the negative X and the negative Y coordinates of the center of the circle, respectively. Okay, so you do not have to go and complete the square, expand everything out if you have already memorized this straight away. If you haven't, then you need to work it out. Okay, then for the final one, C, we have C is equal to, a radius. The radius is equal to square root of -8 square plus -2 square minus away C. This is the formula that we can use. Radius is given to be √80. In other words, 80 is 64 plus 4 minus C. C is going to be -12. That's all. Any questions?